Okay, we have now three charges that lie along the x-axis. So they are located here over the x-axis, as you can see. One positive charge Q1 located at 2 meters and it has a value of 15 microcoulombs. Another positive charge Q2 that is equal to 6 microcoulombs is located at the origin or at x equals 0. At what point on the x-axis must be a negative charge Q3 be placed so that the resultant force on it is considered to be 0. So for this type of exercises, as you can see, we have, well, three charges where you know everything about Q2 and Q1, and the middle charge could be unknown, you don't need it, but you do need the distance, okay, between the two charges. Now, as you can see, the distance is 2 meters, okay, 2 meters. So I don't know at what separation they are from the origin. I don't know this, okay, so I need to arrange it. So I can use algebra for it. I can say that the unknown, this distance that is unknown, I can call it with a variable, could be d or x, depends on you. And this distance right here, it's going to be all the distance, that is 2 meters, but subtracting d from it is going to give you this distance. Now, how can you solve this type of exercise? Well, because it says that the resultant force on it is 0, that means that the force that is coming from Q1 to Q3, as you can see there, it is a traction force. So they want like to be together. Remember? Attraction, they love each other. Here, positive, negative, they are going to feel attracted to. Okay, so these are the two directions of the two forces. Okay, now for this to be accomplished, the resultant force to be 0, you need to equalize the two charges. Okay, so you say force 3,2 equals force 3,1. Now when you do that, you know that the formula to get the electric force is what we know as coulombs. And this is coulombs, okay? Force equals Kc, the charges that are involved, and the distance between the charges. So, because I am talking about the electric force between the particles 3 and 2, I'm going to use all the information I have. So I know that I need Kc. I know because I have the charge Q3, 3 and 2, I'm going to be using Q3 and Q2. The distance between the two particles is, okay, between these two particles I have a distance that is d to the second power. In this other side, between these two, what do I have? Kc, Q3, Q1 divided by, okay, what do I have here? What distance I have between Q3 and Q1? Let's see. 2 minus d. And all of them are raised to the second power. Okay? So, what we do now is we're going to cancel those values from the formula that are the exact same and doing the exact operation. For example, Kc. Kc is in the top of my formula, so that means that the two of them are multiplying. And because Kc is a constant, that means that it's the same number. So this Kc can be eliminated. Now, Q3 is equal to Q3. Even though I don't know the value, I don't need it because it's going to be eliminated. Q1 and Q2 are not the same. Okay, they are different particles with different charges. Look. So now your equation is going to be reduced to the following. Q2 divided by D2 equals Q1 over 2 minus D to the second power. So now what you do is you do a cross multiplication to isolate. Okay? So Q2 is going to multiply 2 minus D to the second power, and Q1 is going to multiply D to the second power. Now, what we do in order to eliminate the powers is that we get a square root, but because we are talking about an equation, you're going to do the same step in both sides of the equation. Okay? So you are going to have what? You're going to have square root of Q2 times the square root of 2 minus D to the second power equals square root of Q1 times the square root of D to the second power. Okay? So remember, because we have square root, we eliminate the powers. Here and here, here and here. So what we do now is we do a replacement. Instead of Q2, we're going to write the value of it. Okay? Square root of 6 exponential that multiplies 2 minus D equals square root of Q1, that is 15 times 10 to the negative 6, that multiplies D. Okay? So after you do that, it comes distributive property. This times this times this. Okay? And here you don't need to multiply because you don't know what D is. That's what we are looking for. So I'm going to replace the square roots by the values now, because for me it's a lot more difficult to multiply like this. So I do square root of 6 exponential negative 6 gives me, and here I'm going to use a lot of decimals, as you can see. Okay, so let's see, 0.0024 that multiplies 2 minus D equals, now I'm going to do the same, square root of 15 exponential negative 6 gives me 0.0039 rounded D. So right now what I do is I actually apply the distributive property. So 0.0024 times 2 gives me 0.0048 minus 0.0024 times d gives me 0.0024 d equals 0.0039 d. Okay, so what we do is I'm going to place my variables, d. I'm going to put them in one single side. So this one is subtracting, goes to the other side to add. So you're going to have 0.0048 equals 0.0039d plus 0.0024d. Because they have the same variable d, okay, because we have the same, that means that we can add them because they have a common factor, okay? So you add them, 0.0039 plus 0.0024, that gives me 0.0048 in this side equals 0.0063d. Now we isolate d. I'm going to continue in here. Okay, so you have 0.0048 equals 0.0063 d. Okay, so this term is multiplying d, so goes to the other side to divide. So you're going to have 0.0048 divided by 0.0063 equals d. So you do this in your calculator now. 0.0048 divided by 0.0063 gives me 0.76. Because we're talking about distance, this will be meters. And voila, this is it. The charge 3, to answer the question, charge 3 should be placed 0.76 meter from the origin. So you can write the answer here, that d is equal to 0.76 meters, and here the distance is 2 minus d, or 2 minus 0.76, that gives me 1.24 meters. To make sure, you can add them, the two, to see if you have the two. 1.24 plus 0.76, 2. So this is it about equilibrium. Good luck.